Hi, welcome to Key Skill 1. We're going to learn what is a factorial and what the notation for an NCR is. This is going to tie in with binomial expansion later on when we're looking at the coefficients. So first of all, what is a factorial? For example, what's 5 factorial? Well, you start at 5 and you keep going backwards all the way until you get to 1. So 5 times 4 is 20, 3 times 2 is 6, 20 times 6 is 120. If you wanted to do it on your calculator, you would type in 5. For me, it's up here. You're looking for the little exclamation mark. So 5 factorial is 120. Now, it's important that you know how to simplify down fractions that contain factorials. And this is my tip. If your fraction contains a factorial, open up the top fraction as far as the lower. Now, by lower, I don't mean the number on the bottom, I mean whichever one is the smaller factorial. So 10 is bigger than 7, so I'm going to open up 10 as far until I get to 7, then I'm going to stop. Now 7 factorial would mean that 7 times 6 times 5 times 4 times 3 times 2 times 1. But I'm not going to write that out, because I know if I open up my bigger factorial as far as my smaller factorial, I can cancel them off. If you were going to write it out full, you would have times 7, times 6, times 4, times 3. And you would have the same on the bottom. But it's not necessary to open it up and cancel it one by one, because, so imagine now you're going to cancel that 7 for that one. You're going to cancel that 6 for that 6. You're going to cancel that 5 for that 5. And you're going to keep going all the way along. But it's easier just to cancel 7 factorial for 7 factorial. Now, what's that going to leave us with? 9 times 8 is 72, so 10 times 72, 720. So, the moral of the story is open up your bigger factorial until you reach your smaller factorial and cancel down. Those of you that did further maths may be familiar with this notation. This is pronounced 5 choose 2. And it's used in permutations and combinations. We're not going to use it in that context today. Now, what is the formula if it's n choose r? Well, there's a formula and it's actually in your formula booklet. The formula is as follows: n factorial divided by r factorial, n minus r factorial. So in this case, we would say 5 choose 2 is 5 factorial divided by 2 factorial, 5 minus 2 factorial. You need to work this out first. It's not okay to say this. 5 minus 2 factorial is 5 factorial minus 2 factorial. Like, that's not going to work. You should work out your brackets first in the order of operations. So 5 factorial divided by 2 factorial, 3 factorial. Open up my bigger factorial until I get to my smaller one. Well, I'm going to use 3 in this case. That will cancel for that. 2 factorial is just 2, so I'd have 5 times 4 divided by 2. The answer is 10. Now, whilst you can type in fractions with factorials, so your calculator will do it. Your calculator has a special button for 5 choose 2, and it's here, 5 choose 2. So we've got 2 ways to do this so far. We can open it out and cancel it down using the formula, or we can use the calculator. Now, what is going to be the third way to do it? Well, we already talked about in the little intro video, Pascal's triangle. So if I've got Pascal's triangle, this line relates to 2 choose, for example, 2 choose whatever. So this would be 2 choose 0, 2 choose 2, 2 choose 1, 2 choose 2. Now we want to get to 5, so we've got to go a bit further. So if you were going to write these all in, this would be 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. So for example, instead of typing in, if I wanted to get the answer straight away for 3 choose 1, I know it's here. This one would be 4 choose 0. Okay, and we're interested in 5, so we wanted 5 choose 2. So we would need to be down here. 5 choose 0, 5 choose 1, 5 choose 2. So the third way to get your numbers, if you need to know something, choose something else, is to look at your Pascal's triangle, and you can write it out as far as you need to go. So 5 choose 2 for us here, 5 choose 2, 10. Or typing it, 5 choose 2, 10. Or third way to work it out is to expand it out using the formula. Now, it's not okay just to say, oh, I'm always going to use the triangle on my calculator, so I don't need to use the formula. Later on, we're going to be doing with algebraic problems where you need to know the formula, because instead of having a number in here that you can type into your calculator, you're going to have an n. So you need to know that formula. Okay, imagine we needed to write this in terms of n choose r notation. Now, you can write this two ways. You can write n choose r, or you can write it like this. Oh, sorry. N choose r. Both of those mean exactly the same thing, and both methods of writing it down are perfectly acceptable. Now, in this case, we need to compare what we've got to the formula. Times by n minus r factorial. So if we compare it to our formula, we can see that n is going to be 4 and r is going to be 3. However, there's another point that if we were to write this the other way around, because 2 times 3 gives you the same answer as 3 times 2. So if we were to write 1 factorial times by 3 factorial, we could also have this as being 4 choose 1. And in fact, in our Pascal's triangle, you'll notice that 5 choose 1 and 5 choose 4 give you the same answer. Or so does 4 choose 1 and 4 choose 3. Okay? So we need to notice that n choose r will give you the same answer as n choose n minus r. And the reason is, if we compare the formulas, so that would be the formula for n choose r, where if we applied the formula here, we would have this one. We would start with the bottom one, n minus r factorial. And in this one, we always do n minus, we always do here. It's useful to think where the numbers are. This one is always the top one. This one is the bottom one. And this one is top minus bottom. Okay, so for example here, top being 4, bottom being 3, 4 minus 3 is 1. Now, here, top minus bottom will be n minus r factorial. And if you multiply the minus m, you end up just getting r factorial here. And because multiplying gives us the same answer, it doesn't matter which way around we have, we can prove that n choose r and n choose n minus r are always going to give us the same answer. And that is exactly why, for example, 3 choose 1 will be the same answer as 3 choose 2. To do 11 choose 0, you need to know that 0 factorial is going to be 1. So 11 choose 0 is going to be 11 factorial divided by 0 factorial divided by 11 minus 0 factorial. Because 0 factorial is just 1, and 11 minus 0 is just 0, we get 11 factorial over 11 factorial, which is just 1. And similarly, for any number, choose 0, it's always going to work out exactly the same. So any number choose 0 is going to be 1, because you're always going to be left with n factorial divided by n factorial. It doesn't matter what n will be, which will be 1, which is why in our Pascal's triangle, the choose 0 number is always 1. Similarly for 8 choose 8, if we were expanding this, 8 choose 8 would be 8 factorial divided by 8 factorial times by top minus bottom, 8 minus 8 factorial. So that 0 factorial here would be 1, and we'd have 8 factorial divided by 8 factorial, which would just be 1. And if we wanted to prove it, n choose n factorial top, that would be the bottom, top minus bottom, So we would have n factorial, that 0 factorial would be 1, or n factorial times by 1, and they would cancel out and you would get 1, which is why n choose n is always 1. And again, if we look back at our triangle, 2 choose 2 is 1, 3 choose 3 is 1, 4 choose 4 is 1, 5 choose 5 is 1. So these ones at the ends here are always going to be 1. That brings us to an end on key skill 1. Hang around, take a break, have a cup of tea like I'm gonna, and I'll see you in key skill 2.